Hi, this is Miss Prez, and I'll be going over difference of two squares with you. In the last few videos, let's see, the first video I think we did was when a equals 1 and we factored and there were certain steps we needed to take. The next video we did was when a is greater than 1 and there were certain steps we needed to take to factor that. And that was all on the idea that our quadratic looked like this, ax squared plus bx plus c, right? That's really familiar. So there's a first term, there's a middle term, and there's a last term. And we had, two ways we were going to factor based on what a was. So now what I'm going to do is show you kind of like a special case scenario of factoring. And what I like about this factoring is that it's really easy to identify, right? So if you have something like this is the example. Notice the middle term is completely missing, right? We have an A, we have a C, but the middle term is missing. So there's only two pieces to this problem. So that makes it really easy to identify, oh, okay, this is a difference of two squares. This is how I'm going to solve this one. So I even kind of put that in stars right here. Middle term is missing. That's kind of how you're going to identify it. So in your notes, go ahead and write factoring a difference of two squares as your title. Make sure to have this formula up at the top, handy. That's the formula that we're going to be using. I would write it in parentheses though. I would say I would write it as a squared plus b squared and put those in parentheses. So I'm rewriting this like this. And then, obviously a plus b times a minus b. So I would write the formula like this in parentheses, only because we're going to be using those parentheses to kind of like identify certain pieces. Some parts of the problem I typically find students have trouble with. So I use the parentheses to kind of help identify those patterns. So now that you have that, let's go ahead and move on. Oh, right. Before we actually get into solving the problem, I need to remind you what perfect square numbers are. And this is just how I say them, but perfect square is pretty much the expression used. So perfect squares are, 1 squared, 2 squared, 3 squared, 4 squared, and all the numbers. So when you see any of these numbers in your problem, right, you immediately like, oh, hey, that's a perfect square. That's a special number. And so, yeah, we do have them. And I would, if you're not real familiar with these, if you can't just look at a number and go, oh, hey, that's a perfect square, then write them down. I would write all the way up to 13, because I would say you would see numbers as far as up as that usually. I'm going to go up to 11 just because that's what we have here. But have these in your notes somewhere, handy, so you can use them at different problems throughout the class. And then now that we've kind of reviewed that, I'm going to use these kind of titles or names to move forward. So this side is called perfect square numbers, and this side is called the squared form. And that's just my own lingo. It's not, official. Okay, so step 1, change perfect square numbers back to their squared form. So I'm going to go ahead and rewrite the problem that we have, which is 4x squared minus 121. Okay, so we want to change the perfect square numbers, which is this side, back into the squared form. So let's find it. Let's find 4, right? So 4 is right here. We want to change the 4 back into its squared form. So let's go ahead and do that. Let's say this is now 2 squared officially, and then everything else stays the same, right? But we also see that 121 is also a squared number, and a perfect square number, and now we want to change it back to its squared form. So let's actually, take the 121 and change it. So now I haven't changed the value of this problem at all, have I? Because 11 squared is 121, 2 squared is actually 4. So the value of this problem has not changed at all. The value of it has stayed the same. I'm just changing the way it looks. And that's a lot of algebra. Just changing the way things look so we can solve it. Now, what the next thing I'm going to do is where students really trip up for some reason. So that's kind of why I wanted you to rewrite your formula as, oops, that's a 2, as a parentheses squared plus parentheses b squared equals, your a plus b, a minus b thing. But the main thing I want to emphasize is the a and b in parentheses. Okay, so what our whole goal is to make this look like this. Okay, so we want those two things to look similar, so we can then identify a and b. So your next step right here is to just kind of combine these squares into one. So we're gonna pull the 2 and the x inside parentheses and leave the squared on the outside. And that's what you'll do for all these problems, really. You'll change the perfect square number into the squared form. From there, you're going to pull those things into a parenthesis and leave the square on the outside. And then we're going to have 11 in parentheses as well. Okay. Okay. And that looks really good because now this kind of looks like our formula. So I'll kind of match it up there. Oh, I knew that wasn't going to work out. It's okay. So I'll kind of rewrite it down here a little bit. So you can kind of see this first half looks like this. So this is a squared minus b squared. So you can kind of see that you have, let me get a color in here. You can see that there's something squared, right? Oops, something in the parentheses squared minus something inside parentheses squared, something inside the parentheses squared. So you can see these are set up very similarly now, and we can easily identify what A is and what B is, because it's just whatever is inside the parentheses is what A and B are. Okay, and that's kind of our next step. So let's kind of move on to the next thing, where step 2, identify A and B in the formula. So let's kind of move down a bit. So just so you can see in your notes, and for your notes' sake, what I would do is just keep going down, keep going down, and then right here below what I have, go ahead and write step 2. Right? Actually, I'll just copy it. I don't need an extra page. I'll just copy step 2 and put it here, so that way it's not confusing. Oops. There we go. Okay, so now you can see that we're all in a nice flow. So we have the title, we have the formula, we have step 1, we have all this written down, and now we're on step 2. Okay, step 2, identify A and B in the formula. Remember, it's everything in the parentheses. It is everything in the parentheses. So I'm just going to kind of copy and paste this last part that I had from above. Actually gotta kind of missed some stuff. Missed an 11 and a squared. Okay, and a minus sign. Okay, so now I have this kind of set up, right? And I'll actually rewrite my formula down here, right? So that, this was the a plus b, a minus b kind of thing. So, but before I do anything over here, let's do this. Let's identify A and B in the formula. So A is, directly what's inside the formula, inside the parentheses. So I would say A is 2x, and then B is what's inside the parenthesis here. So B equals 11. And that's all it is. So really, you don't actually need this side yet. You just need, the left-hand side of the formula. Okay, so but for some reason, students really have a hard time identifying A and B, right? They want to say A is just the X, or A is just the 2, but really it's everything that's enclosed in that parenthesis. Okay, and sometimes it gets kind of big. So let's move on to step 3, which is plug into formula. So step 3, I'm going to keep moving down here. So I would say actually plug values of A and B into formula. So let's go ahead. I'm going to copy and paste this right here, down here. So our formula that we have from up top at the beginning was A plus B times A minus B. Okay, so now that we know that, A, so we kind of just put parentheses here. So now that we know A is 2x, let's put a 2x in for all the A's we see. Okay, well, we see an A here, so I'm going to put a 2x. Well, we see an A here, so I'm going to put a 2x. Now we know B is 11, so wherever we see a B, I'm going to put an 11. 11. And then the signs stay the same. So this is still plus and this is still minus. It would be different if this was like a negative 11, then obviously we'd have to account for that, but it's not. Okay. And then that's kind of your solution. You've factored this this quadratic. So originally you had 4x squared minus 121. That was your original problem. So the factored form is this. The 2x plus 11 times 2x minus 11. Now, if you wanted to check it, you could FOIL this out and just make sure this is true, that this, this is equal to it. So that's pretty much it for factoring difference of squares, really. You just have to, be able to identify a perfect square, change the perfect square into a perfect squared form, identify what A and B are, plug them into the formula, and then you have your factored form, right? I do have another example on page 4, I believe. Is it page 4? Must be this page. Yeah, here we go. So this is, again, special case factoring, and I have the formula written up above here. And this is the new problem. 9x squared minus 16 equals 0. So we're going to change the perfect squares into numbers. So we change 16 into 4 squared, and we changed 9 into 3 squared, right? And then we pulled out the squares. Step 2, identify A and B, which is everything inside the parenthesis. Step 3, plug into the formula. So this is just a quick second example that I wanted to show you, just to have some eyes on. You could copy this one down in your notes as well. Let me know how you're doing in this. If you need extra help, you can message me in chat. You can leave a comment. If this video was helpful, to everyone in the class. So hopefully it was helpful. All right. I will continue making these videos, and hopefully, they're useful. Talk to you soon. Bye.